Yeah, let's solve this question. Uh, Capacity to ship packages within DDS. Given question is that a conveyor belt has packages that must be shipped from one port to another within days. The highest package on the conveyor belt has a weight of I. Each day we load the ship within packages on the conveyor belt in order to given weights. We may not load more than the maximum weight capacity of the ship. Return the list capacity of the ship that will result in all the packages of the conveyor belt that must be shipped within days. Yeah. A game question is that you have to given weights of the conveyors of the packages in increasing order, and you have to given the details. And in one day, you cannot ship packages that has weight more than the maximum weight capacity of the ship. So, and you have to also ship all the packages within the given days, total number of days. So, so for this So, for this, what we can do that is we have to minimize the weight capacity of the ship. Means if you just like this is our example, and I will try to show this how can we solve. Yeah, this is our example, and you know that if total weight capacity of the ship will be 55, then we can you can supply this within one day. If our weight capacity will be approximate 40, we can ship in 2 days. So we have to solve you have to minimize this. You have to minimize this, and you have to solve it for given number of days. Means we we utilize more total days, and have to minimize on this. And by calculation, you can see that if shipping is possible in D days, then it can also be shipped in D minus 1 day. So it's just but- and we have to check that it can it possible for D can it possible for day plus 1 day or not. So what you can do that what you can see that this is like a monotonic behavior, and this things and this giving a hint as a using for using Gandhi sir, and let's try to solve using Gandhi sir, and what can be our low and high. So wha- for for Gandhi sir, we have to choose our low and high, and what low we can choose that means what is the minimum number of weight we can keep in one day. That is given our given weights of 0, and our high what we can what weight we can supply in supply that is sum of all the weights, and we try to use binary weights and find if I can supply this much weight in D days, then you can also then we try to we try to we try to minimize weight that this weight can be shipped in D days, No, and by running binary search, we can find out our most optimal solution. Okay, I'll just try to code it. Uh, Given in constant is 500 over 4 and width I 500, and that means integer will not overflow. Let's take low, that is width of. Let's first try to sort the width if given width is not sorted. First we try to sort the array if if given width is not sorted, and let, for the new line search we have to take a low that will be lowest weight that it gets a supply, and because if we given if this will be n, then our capacity will be max element in array. So let's look into it, and I is equals to width of let's try to do some. Okay, this time. Second, and let's try to find out our answer, that is in answer. But ho- uh, let's try answer equal to high, because if given number of days is 1, then we have to, the capacity will be uh, high. The capacity will be some of the all the weights present in the packages. And let's try to solve why. So let's try to solve like binary such code. Uh, let's try to divide a high and low. I am using high plus low divided high plus high minus low divided 2, because to avoid integer overflow, and if possible means if we can supply we can ship this much of it, and in this we can ship, then it means our answer will be and we have to minimize the capacity. So we go to our we go to lower capacity, that is why min minus 1 is high is equals to is low. If not full, then we have to try to increase our capacity. After we have to return answer, and let's try to write our function which is check whether this much width supply is possible using given dates or not, within given days or not. And let's take in count for zero how much day will taken, how much day we need to, and int into starting that will be with our, and let's try one root for I is equals to 0. I less than weight, I less than weight plus size, I plus plus. If and I exclude, and if weights of I minus st is less than or equals to 0 means means it's a by greater than st. So what we can do? Uh, Sorry, st minus st. Width of I. Let's try to solve. Let's try to is specific function and how to write this. Let's design a loop and our counter will run because we is starting from a first day and I will loop from 0 to all the words and that is vector size y plus plus. And if I encounter any weight that is greater than our mid means this weight is greater this weight is greater than our mid means maximum this weight is greater than maximum capacity means this weight cannot be supplied so we just return false and if given st minus and weight supply means we are not able to we means we are not able to supply this much of weight. So what you can do, we will post this package to uh, Nishkit and that will be that I will increase our D plus plus and in the next day what we will do we will package this and our capacity and our capacity will remaining that is weight supply and we have to return if count if total number of days is within the days then we just return true. Just try to run and solve it. Yeah, there it is. We given one answer for this test case. Let's see what let's see why our code is wrong. This is our example which is wrong. Let's sort the array and this will be our this will be our final array that is looking like this. 1 2 3 4 5 6 7 8 1 2 1. Let's small this one, 1 2 3 and 4 4. If our maximum weight is 7, then we can supply this much of in 1 day and this much in 1 day and this in 1 day. Means we can supply in total 3 days. If our max supply is 6, then we can supply in 1 day in 1 day and it's taking 4 day means our logic is wrong and for let's erase this and try to solve for n equal to 6. So let's for n is equal to 6 for minimum capacity will be maximum capacity is 6 we can supply in order of like 2 and 3 then 1 and 4 and 4. Or maximum, what is our maximum capacity minimum to 5. And if you take 2, 3 and 2, 3 and 4, our maximum capacity will be 6. So means we can take we can take element from 3 to let's let's take did we misunderstand the problem or not? Yeah, we are given by words, so we cannot sort. You cannot sort the bit. So let's try to solve this. Yeah, this is accepted because we cannot sort the weight because we only receive the packages in given to our weights. So let's try to submit our answer. Yeah, this is submitted, and let's see the time complexity and space complexity of my code. This is my code which beats up 60% of people in space time complexity and 40% people in space complexity. And our time complexity is O n to log of sum of weights, and our space complexity is O of 1 because we are not using any space for solving this. This is our answer. Uh, Uh, there are many questions on in this pattern. We will try to solve this in the upcoming classes like missile compared with full capacity of rocks and minimum total distance travel. Yeah, that's all for today. Let's in this lecture. Yeah. Okay, bye. See you.